This is exercise video number 8, and for my exercise today, I ran 1.5 miles with a pace of 8 minutes and 43 seconds. And so during this exercise, I was likely predominantly in the glycolytic system. And so my body was converting carbs into usable energy into ATP. And so glucose was going through glycolysis, and then you eventually end up with 2-pyruvate. That pyruvate can either go to the Krebs cycle, be converted into acetyl-CoA, and then eventually NADH, FADH, and GTP will all be used to generate ATP. FADH and NADH go into the electron transport chain, which allows you to generate ATP through that. And so whenever I was breathing in, I was taking in oxygen, and that oxygen was going into the third pump on the electron transport chain and allowing that system to continue running. However, during my run, I was most likely in the fast glycolytic system. And so I was primarily burning carbs. And so the ATP that was made during glycolysis was used in the sodium-potassium pumps. And so what happens is whenever I'm running, my neurons, my motor neurons that are not touching the muscle cells, but they are near them. So what happens whenever I run is my body's getting sensory input, and so it is telling my muscles to contract. And so I was getting afferent input to my central nervous system, and then that was telling me to move my legs or to contract my quads whenever I was running. And so what happens in that system is there are neurons that are near your muscle cells, not touching, but they're near them. And so they receive a stimulus at the dendrites. That stimulus is then integrated in the cell body, and then that stimulus travels down the axon, which is a long, it's just the long part of the neuron. And so that axon propagates the signal, and so that signal is being depolarized, repolarized, depolarized, repolarized, depolarized over and over again. And then eventually you reach the axon terminal and the synaptic bulbs. And those synaptic bulbs are what are not touching but are near the muscle cells. And in these synaptic bulbs, we have synaptic vesicles, and the depolarization of the cell allows the synaptic vesicles to exocytose neurotransmitters in the synaptic cleft near your muscle cells, and those neurotransmitters can either cause contraction, which is excitatory, or inhibit contraction, which is inhibitory, or no change happens.